Alright, welcome to 9.6 Similar Solids. So we're going to start with looking at something we learned a little bit back in Unit 5, similar. So the idea is if two polygons are similar, then the ratios of the parameters are also similar. And we're going to find that out about their areas as well. So this is 48 to 8, so the ratio is 6 to 1. And so the ratio of the parameters is also 6 to 1. And the ratio of the areas, we have to first find this missing side length. It's 6 times bigger, so 6 times 6 is 36. So that missing side length is 36. So the ratio of the areas, 36 times 48, is 1,728 to 6 times 8, which is 48. So that's the ratio of the areas. But what we know is that 36. This simplifies down to 36 over 1, which is just 6 squared over 1 squared. So the ratio of the areas, it's two-dimensional, so it's squared. You just take their length and you square it to create the ratio. So that's our theorem, is that the side length of polygon 1 and the side length of polygon 2 is a to b. Therefore, the area is a squared to b squared. So if we look at this, a large rectangular cooking pan is 15 inches long by 10 inches wide. Smaller pan is similar. The area of the smaller pan is 96. Find the width of the smaller pan. So we have a small pan here. The area of the smaller pan is 96. So this is 10 by 15 for the big one. The area of the rectangular pan that's big is 150. The small one is 96. So we do 150 to 96. Right? And then that's 16 to 25. So we know the length is 4 to 5. Right? And then we set up our proportion. X is to 10 because we know that those match on the bottom there. So we get 40 equals 5x, so x equals 8. The floor of a fancy gazebo is a rectangular octagon. Each side of the floor is 8. The area is about 209 square feet. You like to build scale models, so you decide to build a model of your gazebo. The perimeter of the floor of the model gazebo is 24 inches. Find the area of the floor model gazebo to the nearest tenth of a square inch. So you got the octagon here. It's 8 feet, and the area is 209. We have the smaller one here, and we know the perimeter is 24, so the length is 3. And we want the area of the small one. So this is 8 to 3. The perimeter is 64. 64 to 24, 8 to 3. And then we square them to find area. So 64 over 9. And then we're going to set up proportions. 64 is to 9 is 209 is to x. Cross multiply, we get 64x equals something. Divide by 64 and you get 29 square inches. So here, identify whether the given rectangular prism is similar to the right rectangular prism shown to the right. So it's 8 by 4 by 2, and then 6 by 3 by 3. So what we do is 4 over 8 is 1/2, 2 over 4 is 1/2, and 2 over 2 is 1/2. There is 1 over 1. And then, so what we're doing is we're basing it compared to the rectangular prism to top right. We know that it's a square prism. So knowing this first one is a rectangular prism doesn't really work for us. This next one, it is a square prism. So we just have to check the ratios to see if they're the same. 4 over 6 is 2/3. 2 over 3 is 2/3. And 2 over 3 is 2/3. So this one is correct. This one is similar. It's a square pyramid or square prism, and they both have the same ratio. The height and the base have the same ratio. Okay. Now let us explore the volumes and surface areas. So here, these are regular. The smaller one is 2 to 3, but the area of the base of the small one is 4 times 2, which is 8. The height, the perimeter is 12. Because we're looking at the surface area, we do 2 times 8 plus 12 times 2, and we get the surface area is 40. On the larger one, the base is 6 by 3, which is 18. The perimeter is 18, 6 plus 6 plus 3 plus 3. And then we do 2 times 18 plus 18 times 3, which is the height of the prism, and we get 90. So the length is 2 to 3. The area is 40 to 90, which simplifies down to 4/9, right? 2 squared, 3 squared. And then the volume, so the area of the base is 8 for the one, still the same, times the height, which was 2. 8 times 2 is 16. The larger one, the base is 6 times 3 is 18 still. The height is 3. 18 times 3 is 54. So this is 16 over 54, which simplifies down to 8/27, which is 2 cubed and 3 cubed. So it's a cubed and b cubed. So our idea here is that you have length, which is a to b, you have area, which is a squared b squared, and you have volume, which is a cubed b cubed. So we can look at this one right here. The cans are similar. Their scale factor is 87 to 100. Find the surface area and volume of the larger can, given the surface area and volume of the smaller one. So we have the smaller one. The surface area is 51.84. The scale factor is 87 to 100. So the scale factor of the area is 87 squared, 100 squared, which is 7,569 over 10,000. And then we can set up our formula. We have the smaller one, 51.84, over the surface area of the bigger one, cross multiply, and we get 69.49. Now we got to cube it, so 87 cubed, 100 cubed gives us 658,503 over a million. And then we have the volume 28.27 over phi to find the volume of the bigger one. Cross multiply and we get 42.93 cubic inches. The pyramids are similar. The pyramid P has a volume of 1,000. Pyramid Q has a volume of 216. Find the scale factor of pyramid P to pyramid Q. So we're going to do 1,000 over 216. And because it's a cubed, b cubed, we're going to take the cubed root, and we find that it's 27 over 125. Oh, that's what it simplifies down, is 27 over 125. Then we take the cubed root, and we get 3 over 5. Alright, that's it for volume. Good luck on the practice.